Our sun, the anchor of our solar system, won't shine forever. It's a brilliant star that has been burning for about 4.6 billion years, providing the energy necessary for life on Earth. Like all stars, it has a life cycle. Stars are born, they live out their lives, and eventually they die. The sun is no exception to this cosmic rule. Right now it's happily fusing hydrogen into helium, releasing the energy that bathes us in sunlight. This process, known as nuclear fusion, is what makes the sun shine so brightly, but in billions of years the sun's fuel will dwindle. As it exhausts its hydrogen supply, the sun will undergo dramatic changes. As hydrogen runs low, the sun will expand dramatically, becoming a red giant. This phase will mark the beginning of the end for our sun. This bloated giant will engulf the inner planets, including Earth. Our home planet will be consumed by the sun's outer layers. It's a dramatic end to our home planet, but a natural stage in the life of a star. The sun's transformation into a red giant is an inevitable part of its evolution. After its red giant phase, the sun will shed its outer layers, leaving behind a dense core called a white dwarf. This remnant will be incredibly hot and dense. This white dwarf will slowly cool over trillions of years, eventually fading into a cold, dark cinder. It will no longer emit light or heat. The sun's story, from bright star to fading ember, is a preview of the universe's fate. It reminds us of the impermanence of all things, even the stars that light up our skies. Across the cosmos, stars are going through similar life cycles. Massive stars explode as supernovae, leaving behind neutron stars or black holes. Less massive stars, like our sun, become white dwarfs. Over eons, the universe will become a stellar graveyard. Imagine a night sky where the familiar twinkle of stars is gone. In their place, only the faint glow of dying white dwarfs and the invisible pull of black holes remain. The universe will grow darker and colder, a stark contrast to its vibrant beginnings. Trillions of years pass. The white dwarfs, once glowing embers, continue to cool. Eventually, they reach a point where they no longer emit light, becoming black dwarfs. These black dwarfs are incredibly dense, holding the mass of a star and the size of a planet. But even black dwarfs may not last forever. Some scientists believe that protons, the building blocks of atoms, might decay over unimaginable timescales. If this is true, even black dwarfs will eventually dissolve into radiation, leaving the universe a sea of particles. Section 4. Black hole drama. While stars fade, black holes will have their moment in the spotlight. These enigmatic entities are the ultimate powerhouses of the cosmos, drawing in everything that comes too close. These cosmic monsters, formed from the collapse of massive stars, will dominate the universe's gravitational landscape. Their formation is a dramatic event, marking the end of a star's life and the beginning of a black hole's reign. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. The event horizon marks the boundary beyond which escape is impossible. However, even black holes aren't eternal. Despite their immense power, they are subject to the laws of physics and will eventually meet their end. Through a process called Hawking radiation, they slowly lose mass over time. This phenomenon, proposed by physicist Stephen Hawking, suggests that black holes emit radiation and gradually shrink. This evaporation process is incredibly slow, taking far longer than the current age of the universe. Over eons, black holes will lose their mass and energy, fading away into nothingness. But eventually, even black holes will disappear, leaving behind only faint traces of radiation. The universe will be a quieter place, with the echoes of these cosmic giants lingering in the void. Section 5. The universe's last breath. After the black holes evaporate, the universe will enter its final stage, the dark era. This is a time when the universe will be devoid of any significant sources of energy. The once vibrant and dynamic cosmos will have transformed into a cold, desolate expanse. At this point, the universe will be incredibly cold and empty. The stars that once illuminated the night sky will have long since burned out, leaving behind a vast, dark void. The temperature will drop to near absolute zero, making it inhospitable for any form of life as we know it. Matter as we know it will be gone, replaced by a scattered sea of low-energy photons and other fundamental particles. These particles will drift aimlessly through the void, with no interactions to create new structures or forms of matter. This is the ultimate fate of the universe as we understand it, a state of maximum entropy, where nothing much happens. In this state, the universe will have reached thermodynamic equilibrium, meaning there will be no energy gradients to drive any processes or changes. The universe will be a cold, dark void, a far cry from the vibrant cosmos we observe today. The galaxies, stars and planets that once filled the universe with light and life will be nothing but distant memories. The grand story of the universe, from its fiery birth to its slow fade into darkness, reminds us of the vastness of time and our place within this cosmic narrative. It is a humbling reminder of the transient nature of existence and the ever-changing face of the cosmos.